This is Algebra 2 with Trig. We're working on Unit 3B.1. We'll be simplifying, multiplying, and dividing rational expressions. A rational expression is in simplest form if its numerator and denominator have no common multiple. For an example here, if we have an A times a C and a B times a C, we're going to divide out the common factor. In this case, the common factor is a C. So we cross out that common factor, and you're left with your A over B. So doing it with some numbers, we think about what 15 is made up of, 5 times 3. We think about what 65 is made up of. 5 goes into 65, goes into the 6 one time with 1 left over. So it's 5 times 13. So their common multiple is 5, and they're left as 3 over 13. So you're going to divide out the common factor of 5. Here it's written a little bit differently. Often we have to factor to get into this mode. This we're just pulling out our GCF. Here we're doing a full factor. You're looking for any multiples that are the same. You have an x plus 3 and an x plus 3. One on top, one on bottom that can be crossed off. So now we're going to have 4 over x minus 5. So we're going to cross out our common factor of x plus 3. We usually require 2 steps to simplify a rational expression. First, we're going to factor the numerator and denominator. And then we are going to cross out any factors that are common to both the numerator and the denominator. Remember, you can only cancel out common multiples. Things that are separated by multiplication, not by addition. That's going to be the common mistake. So let's come on over and look at this first one. Many people are going to make a mistake and cross out the x squared with the x squared. You cannot do that. The x squared is being added to something. You cannot cross that off. You can only cross off if there's multiplication going on. So we have to pull out our common multiple. So that's a GCF. You could write this one as x squared, or you could write it as x times x, however you like to think about that. But when we reduce this, we're going to cross off this x, and we're going to cross off, there are 2 of them here, right? So we're just going to cross off the exponent, or we're going to turn the exponent into a 1. Now we got rid of one of those x's. Now we're left with x plus 7 over x. Now a common mistake is where people think that they're going to cross off their x's. That doesn't work. If you think about the numbers 2 plus 8 divided by 2, can you cross off the 2's and make the answer be 8? Or is this actually 10 over 2 that's the answer is actually 5? So that helps remind you that you cannot reduce out the 2's. You've got to group together what you can. Typically, they're unlike terms. These are like terms. We got 5. you cannot cross them off and get the answer of 5. It wouldn't work. So think about what you can do here with 1b. Notice you cannot reduce the 4 and the 16. You cannot reduce the x over x squared. We would factor. We would cross off our common multiples. If everything crosses off on one side or the other, we still represent that with a 1. Specifically, the numerator. What can be done with this one? Can we cross off and reduce the x squareds and x cubes? Definitely not, because the x squared is being subtracted with the 2x. It's not being multiplied into something. It's being subtracted. So we're going to treat this first one, the numerator, and break it into 2 binomials. And we're thinking about what multiplies to be 15 and adds to be 2. That's 5 and 3. So we're using our factoring skills again. What multiplies to be negative 15 and adds to be negative 2 would be a negative 5 and a positive 3. With the denominator, this is a cubic. This has 4 parts to it. So the most common way we would factor this is to try a factor by grouping. We would pull out our x squared. That would leave us with an x plus a 3. Bring down your sign. The only thing that factors out of this is a 1. You got to pull something out. You got to have a placeholder. So 1 times x and positive 1 times positive 3. Remember, what's inside the parentheses has to be exactly the same. If it's not, something went wrong. You cannot use factor by grouping without these being exactly the same. So this is x squared plus 1 and x plus 3. Notice that we use x plus 3 only once. We don't write x plus 3 squared. We don't write x plus 3 2 different times. So we're going to use this over there. So x squared plus 1 and x plus 3. So we factored the numerator, we factored the denominator. Now we can cross off our common factors. Notice that the x plus 3, the entire x plus 3, is multiplying the x minus 5. So those are multiplication. Same thing at the bottom. So that's why we're crossing off multiples. We're not crossing off things held together by addition or subtraction. So our final answer is x minus 5, x squared plus 1. (1D). Think about what needs to be done here. What do you recognize? You may notice a GCF with the top, with the numerator. We get x minus 3. With the denominator, you may notice that you can take the cubed root of x cubed. You can take the cubed root of 27. So this is the difference of 2 cubes. So this is going to be x minus 3. Then you square the x, multiply the 3 and the x together and change the sign, and square the negative 3. So your common factors are x minus 3. And we're left with 10 divided by x squared plus 3x plus 9. There's nothing that can be crossed off of this answer. All right, what do we see here? You need to be observant. If you're told what to do, it's pretty simple. But can you decide what needs to be done? You cannot reduce the 27 and the 81 or the 3 and the 81 or the x's. None of that can be reduced. You have to factor first. Now this is x to the 4th power. We don't have any fancy factoring rules for x to the 4th power, so we're going to treat this just like it's an x squared. This is going to be the difference of two squares. So this is going to be x squared minus 9 and x squared plus 9. Those are conjugates of each other. When you multiply that together, the middle terms drop out. Here, what we can factor out, 3 goes into 3, of course, and 3 also goes into 27. So we have a 3x. That leaves us with an x squared plus a 9. So our common factor is going to be to cross those out. Now, it doesn't overly help us in this case, but this here is the difference of two squares. This can be broken down into x plus 3, x minus 3. The denominator, there's nothing else we can do with it. You can't reduce anything. What needs to be done to this one? What are our steps going to be? For the numerator, we're going to use factor by grouping. We're going to factor out the x squared. That leaves with an x plus 2. Bring down your sign. Factor out what you can. Negative 2 times x leaves you with a negative 2x. Negative 2 times a positive 2 would give you negative 4. Notice that what's inside the parentheses is exactly the same. So we get x squared minus 2 and x plus 2. That is our numerator. Then we look at the denominator, and that can factor into x plus 2, x plus 2. So we can cross out our common factors, and we get x squared minus 2. No need for parentheses because we're not multiplying anything else to it. And x plus 2. Can you cross the x's out? Can you cross the 2's out? No. Now we're going to use some of those same skills when we multiply and divide our rational expressions. Multiplying and dividing rational expressions is exactly the same thing as multiplying and dividing numerical fractions. So in this case, when we're multiplying our two fractions together, we're going to multiply the top to the top and the bottom to the bottom. But when we divide, notice that we're going to keep the first fraction the same, and when you're dividing, you're going to flip the guy and multiply. So our example here, we're going to divide. So we're going to take our first fraction, 3a cubed times b over 2c b cubed. You could reduce the b's right now if you wanted to. Times the reciprocal. So now you might notice that you have 3 b's on bottom. You have 5 b's on top. So that's going to actually turn into a 2. That's b squared now. I took away 3 of them. The 1a here is going to cross off with at least one of the a's there in the numerator. Anywhere on the top can cross off with anywhere on the bottom as long as it's multiplication. 2 can cross off with a 10, makes that a 5. 3 can cross off with a 6, and that's going to make it a 2. So let's see what we have left. Across the top, the only number that we have is 5. Then we have one of the a's, one of the b's, and actually 2 more b's. So we have b cubed. In the denominator, we have a 2. We have 1 c and then 5 c's. So that's a total of c to the 6th power. Looks like in the problem we started with a cubed, but I only wrote a squared. So when that got reduced with the a on bottom, that would have left a square left over. Just got to watch all those little exponents. Okay. So you've got a couple different ways you could handle this. You could reduce the x's first in the first fraction. You could reduce the y's in the second fraction. You can reduce the 6 and the 10 in the second fraction. Or you can just kind of slam everything together. If the numbers aren't very big, that might be a good way to do it. 5 times 6 is 30. X squared and x is x cubed and y cubed. On the bottom we have 2 times 10, which is 20. We have an x and a y cubed. So we multiplied our constant numbers, and whenever we multiply the same variable, we add the exponents. So that's going to leave us with crossing out the y's and reducing the x's. We have 3 x's on top, x cubed, We have 1x on bottom, so when we reduce that, we're going to get an x squared on top with none left on bottom. We know that 10 goes into 33 times, and 10 goes into 22 times. So our final answer is 3x squared over 2. But division is going to be a little bit different. Remember, we're not going to actually divide fractions. We really never divide fractions. We multiply by the reciprocal. So it's 7y squared over 8x squared. Nothing there can be reduced. We're going to multiply it by 40x over 21y. We take what we were dividing by and we flip it and multiply. Nothing there could be reduced. So you could multiply it all out if you want. 7 times 40 is 280. You could do that. But also notice that anything on top can cross off with anything on bottom. So 7 goes into 21 3 times, so I reduce that. The 8 goes into the 40. That goes in there 5 times. So the 40 is going to become a 5 now, because 40 divided by 8 is 5. We have 1x on top, and we have 2 x's on bottom. I'll just cross out the exponent, because a 2 would turn into a 1. And the same idea here with the y's. That reduces. So now I'm going to have a 5 with a y and a 3 with an x. Sometimes you may need to factor in order to see the factors. You can cancel. Yes, we can cancel if we can see the factors. We're going to simplify answers are written in complete. Simplified answers are written in completely factored form. So think about what we need to do here. What do you see? What do you think? Make some decisions. Out of this first portion, I notice that they have something in common. They have a 5 and an x in both of those. So that leaves me with a 4 minus x left over. That's going to be a little tricky item to work with. This denominator is going to be an x and an x minus 1. This is multiplying x 4 and 1. So that's got to be a positive 4 and a negative 1. That would multiply to be negative 4, but if you did the outer and inner, you would get the positive 3. And then, of course, the denominator is going to be x plus 4, x minus 4. So we go through here, we cross out our common factors. So the x plus 4 is crossed off, The x minus 1's cross off. And watch this. This is 5x times a quantity. This is just x. So these x's can cross off also. They're not being added onto anything. They're just being multiplied. Now there's something else happening here. We have 5, 4 minus x, and on the bottom we have x minus 4. That kind of looks like the same thing. 4 minus x kind of looks like x minus 4. But if you look closely, the x is the negative here, and the 4 is the positive. It's the other way around down here. So if we factor out another negative out of the top, make this a negative 4 and a positive 1 by pulling out a negative. So it's actually going to be a negative 5. That's going to leave us with a positive x and a negative 4. And I rearranged it. I put the x first. So that's a situation where we get the leftover of just 5. All right, a couple more. Here we're trying to factor the top. We get 3x and x. 3 times 5 and 2. 5 and 2 make 10, and 15 and 2 can make 13. Now we're going to multiply this to this side, but this is division. This is a number over 1. So when we rewrite it, we're going to write it as 1 over the number. And we're going to factor out what we can. So I did that all in one step. You might need to write that in 2 steps. So the 3x minus 2's cross off. That's the only thing. So we're left with x plus 5 and 6x squared. Notice nothing crosses off. Even if this was x plus 6, it would not cross off with the 6. The last row. Here we have x minus 1, x squared plus x plus 1. That's the difference of 2 cubes. So you take the cube root of each of those, you square it, you multiply and change the sign, and you square it. Here with the factoring, we're practicing our guess and check, but you're welcome to use factor by grouping or any other methods that you need. What 2 numbers multiply to be that? We got it. So multiply to be 3 has to be 3 and 1. I just don't know where my 3 goes. So if I did 2 times 3, that would get me up to 6, and I only have a 1 to get me down, so that won't work. It has to be 1 and 3. And that's going to be a negative 1 and a positive 3. And this is not factorable. Nothing multiplies to be 1 and adds to be 1. That actually makes common denominators, and here we can cross off, so we're left with 1 over 2x plus 3. Two more. Why don't you go ahead, try these two, pause the video, work through those, then play the video, and see if the answers match up. So now we'll come back. We'll take a look at the numerator of the first fraction. What I notice is they both have a 3 in it. They both have an x in it. That leaves me with x minus 1, where the denominator is going to be broken down into two binomials. It's going to be 5 and 1. The only way we can multiply to be 5. And that will be, to get a positive, we need more 5s than we have negatives. This is multiplication, so we keep it in the same order. X and x, 5 and 4, positive 5, negative 4, and 3x. So it looks like the 3x's are going to cross off, the x plus 5's are going to cross off, the x minus 1's are going to cross off, and the only thing left over is x minus 4. Now this last one is division. It doesn't affect how we handle the first fraction at all. The first fraction is going to be broken down into two binomials. What multiplies to be 21 and adds to be 4. Negative 4, so you know the 7 has to be the negative. Now we're not going to divide, we're going to multiply. We don't divide fractions, we only multiply them. So when we do that, we have to flip the fraction over. So this is going to be x and x, positive 10, negative 10. We're taking what used to be on the denominator and putting it in the numerator. I've gone right into factoring it. Then our denominator is going to be x and x. To get 70, what is that, 10 and 7? That multiplies to be 70, and they're 3 apart. We need more positives, and we have negatives. So the x minus 7's cross off, the x plus 3's cross off, the x plus 10's cross off, and I'm left with x minus 10 over 5. Don't forget, you cannot reduce the 10 and the 5.